Hi students. Today we are ready to start talking about quadratic functions. So we're going to start with the parts of them. If you have printed out the little booklet that goes with this, do your best to kind of get the pages in order and follow along. I'll kind of remind you what page we're on. Otherwise, if you're just doing this on your notebook paper, please sketch in the little graphs. Try to stay organized. And when you sketch in the graph, sketch in the important parts of them. Try your best. All right. So, what is a quadratic function? A quadratic function, it's a polynomial function. So it'll look a lot like the polynomials we've been working with lately, with its highest degree, which means its highest exponent or power is 2. So the highest exponent is going to be a 2. So when we were doing linear functions, our variable of x had an exponent of 1. Well, now we're having an exponent of 2. And what that does, when you graph it, it creates this nice, beautiful curved shape like this down here, like this purple graph, which is called a parabola. That's its fancy word. Parabola. Okay, parabolas can look like a U shape like they do in this graph, or they can look kind of like a mountain. So they can open down. The one on the left we say opens up, the one on the right we say opens down, and we'll talk more about that. Let's go ahead and look now at what the function actually looks like in equation form. So there are two forms of the quadratic function in equation form that we'll learn about. Recall with linear functions there were three forms. There were slope-intercept form, point-slope form, and standard form. So one of the forms for quadratic functions is called vertex form. Sorry about that. And it looks like this. Y equals a parenthesis x minus h parenthesis squared plus k. So we've got a lot of new variables. We'll learn what they mean, just like when we learned what m and b meant. These are going to be specific to quadratic functions. So vertex form, you want to start to kind of identify this form. Looks like this. Okay, the way that you can notice it is you've got the parentheses. That means you have vertex form. Below it right here is an example of vertex form, and we'll talk about what all the letters mean in a little bit here. But I also want to introduce to you the second form, which is called standard form. And we can actually go from one form to the other, just like we did with linear equations when we would go from point-slope form to slope-intercept form, or from standard form to slope-intercept form. Standard form for quadratic function looks like this. Y equals ax squared plus bx plus c. Now this part right here should look very similar to the trinomials we've been getting after we've been multiplying binomials. So it's going to start to all kind of connect here in a little bit. So standard form, this is the other form you should start to be able to recognize. Okay, so I'm going to show you real quick. You don't need to be good at this right now, but I do want you to kind of be familiar with it. We're going to go from vertex form, which we see right here, to standard form. Make it look like that. Okay, so the very first thing we're going to do is we're going to do our exponents. Okay, that's usually what we do. So what this means, x minus 2 is what is being squared. And so that means x minus 2 times x minus 2. We need to expand it like we did when we were multiplying binomials. So I'm just going to rewrite it like this. 3 times x minus 2 times another x minus 2. And then we have the plus 4. Okay. Now what we'll do, we want to get rid of our parentheses now. Now we have to multiply the 3 by the x minus 2 by the x minus 2. We're going to first multiply the x minus 2 times the x minus 2, just like we did when we had when we were multiplying binomials. So we'll do first, outer, inner, last. So we're going to practice doing that now. So we'll get y equals 3 times, and that trinomial we're about to get we'll put inside the parentheses. We'll put our 4 terms first, and then we'll combine those 2 middle terms. X times x is x squared. X times the negative 2, the 2 outside terms, is negative 2x. Now we're on to the negative 2. Negative 2 times x is negative 2x. And then the 2 last terms, negative 2 times negative 2 is a positive 4. Parentheses, and then don't forget the plus 4 at the end. So we're just doing it step by step. Now remember with when we multiply binomials, we get 4 terms, and then remember those 2 in the middle are usually like, so negative 2x minus 2x, that's going to give us negative 4x. I'm going to rewrite that part. 3 times x squared, and then those negative 2x's combined to make negative 4x. We just add the 2 negative 2's. Plus 4, and then plus 4 outside the parentheses. Now we can multiply that trinomial times the 3. So we'll distribute the 3 to the x squared, to the negative 4x, and to the 4. So we will get y equals 3 times x squared is 3x squared. 3 times negative 4x is negative 12x. And 3 times 4 is 12. And then, of course, we have the plus 4 at the end. So now we're done with our exponents. We're done with our parentheses. We want to look and see if we have any terms that are like. I see our last 2 terms are both constant. So that 12 plus 4, we'll be able to combine those together. They will add to make 16. So y equals 3x squared minus 12x plus 16. And so this is standard form. Notice it looks like this guy. And we started with vertex form. Notice it looks like that guy. Okay, so there were quite a few steps in there. You do need to know how to multiply binomials in order to convert from vertex to standard. All right, now we're going to look a little bit more closely at the graphs. The graphs is our focus now. So now we're on the second page of our book. There are basically 5 parts that we're going to be focused on. The first one is the vertex. When you think of a vertex can be like where two sides come together on a polygon, like a triangle has 3 vertices. Vertices is plural for vertex. In a parabola, the vertex is where the parabola changes direction. And it's either going to be the lowest point on the graph or it's going to be the highest point on the graph. On the parabola. So I said your graph of your parabola can look like these two. These are said to open up. These are the ones that look like a U shape. When your graph opens up, your vertex is a minimum. So the vertex for both of these graphs are going to be these points right at the bottom here. Okay? The coordinates of the one on the left, that's the origin, that's 0, 0. The coordinates of the one on the right are -1, -4. Okay, so sometimes I'll ask you what are the coordinates of the vertex. Now, the general form for vertex, the x coordinate of the vertex we call h, and the y coordinate of the vertex we call k. And if you look back to our vertex form, you can see the h and the k right there. So there is a connection to the equation, but we'll look more at that later. Your graph can also open downwards. So notice the open part of the graph is below. Now it looks more like a mountain. We say that it opens down. Opens down, excuse me. And when it opens down, your vertex is called a maximum. Maximum meaning that it's on the very top of the parabola. So when you had a minimum, it was at the bottom. Minimum means lowest, maximum means highest. The coordinates of the vertex on the left, that maximum is also the origin, 0, 0. And the coordinates of the vertex on the right graph is 2, 1. So you can have all different types of parabolas, either opening up or opening down. Now we're on to the second part of a quadratic function, and that's called the axis of symmetry. An axis is just a line. We have the x and y axes, right? Symmetry is when two parts look the same, right? So an axis of symmetry is kind of like an imaginary line you can draw through something that divides it into two equal looking parts. So for a parabola, that axis of symmetry will be a vertical line. Vertical means up and down. You might want to draw a little picture. It's always going to be vertical with a parabola. It's a vertical line through the vertex. So you may have kind of already noticed that that vertex kind of looks like it's in the middle of the graph. So when we talk about the axis of symmetry, it's an actual line, and the equation of any vertical line we've talked about before is always x equals the number that it crosses on the x-axis. So we'll be able to practice that a little bit more. Let's look at example 1. First of all, the vertex is down here at the bottom. This is an example of a minimum. But if I draw a vertical line through that vertex, that is the axis of symmetry. Notice it looks like we split our U shape, our parabola shape, right down the middle. Okay? So the equation for this axis of symmetry is x equals -1 because it goes through the y-axis at -1. Another connection we can make here, if we go back and look at that minimum, that vertex, it has coordinates -1, -4. The x part of that vertex is also going to help you make the equation of the axis of symmetry. So there's a connection between the vertex and the axis of symmetry. It's the x value. Let's try another one. For this one, our vertex is now a maximum. This is the same vertex from the other page. It was 2, 1. So the axis of symmetry, if I draw a vertical line through that vertex that divides our parabola down the middle, the equation for that axis of symmetry is just going to be x equals the x value of that vertex. So x equals 2. It crosses through the x-axis at 2. Okay? Now, sometimes you don't have a graph to look at. Maybe instead you have the equation. So we'll talk more about this next time, but I want you to write down this formula. There's a formula to find that axis of symmetry, and it is x equals, like we said, but for the number part, you can take the opposite of b, or -b, divided by 2 times a. And you're probably wondering, well, what's b and a? B and a, these come from standard form of the equation. So remember, standard form was y equals ax squared plus bx plus c. So if you have the equation form, you just take out the a and the b, plug it into this little formula, and that will give you the equation for axis of symmetry. It will also give you the x value of your vertex as well. And we'll talk more about that later. The third part of a quadratic function, we're on the 4th page now, is the x-intercept. Now you guys know what x-intercepts are. X-intercepts are where your graph crosses the x-axis. So in this case, it would be where the parabola, excuse me, my handwriting is not working, crosses the x-axis. If you recall, at that point where your graph crosses the x-axis, this is also where y equals 0. So if I don't have a graph to look at, I could replace the y part of my equation with 0 and solve for x. We're going to be doing that later. X-intercepts are a pretty big concept with quadratic functions. You'll see this next year. You'll see it on the TSI. You'll definitely see it on the STAR test. But there are other words that also mean x-intercept that I now need you to be aware of. So they are also known as, aka, the zeros, because this is where the function equals 0 or the y value equals 0. They're called the zeros. They're also called the roots. And they're also called the solutions. I need you guys to know that these 4 words, zeros, roots, solutions, and x-intercepts, all mean the same thing. And you need to start connecting those, okay? So let's go ahead and look. I've got 3 different types of graphs and their x-intercepts. So for each of these, we're going to do 3 things. We're going to look at the vertex of the graph, the AOS, which is axis of symmetry, I'm abbreviating here, and the x-intercept or intercepts, otherwise known as zeros, roots, or solutions. All right, in this graph, this is an example where a parabola has 2 x-intercepts or 2 solutions. It crosses that x-axis at 2 different spots. We'll look at 2 other examples where a parabola will have 1 solution or no solutions. There are different scenarios. So let's go ahead and go through this guy. The vertex of this graph is a minimum. It's at the bottom, and its coordinates are -1, -4. Okay, the axis of symmetry, remember, is a vertical line that goes through that vertex. All right, it's always x equals that x value of the vertex, or x equals -1. And then our 2 x-intercepts, we've got 2 of them. The one on the left is -3, 0, and the one on the right is +1, 0. Notice both y values equal 0 because x-intercepts are where the y values are 0. So this is an example of 2 solutions. Let's look at an example that has 1 solution. So this graph, notice it only intersects the x-axis 1 time. And this will be a unique case. If your parabola intersects the x-axis 1 time, it's going to actually intersect at the vertex, either the maximum or the minimum. So in this case, the vertex is 3, 0. But it's also, 3, 0 is also the x-intercept. So they're the same when you have 1 solution. The axis of symmetry goes through that vertex, and it's always x equals the x value of the vertex, so x equals 3. Okay, as we're going through these, if there's any questions that are coming up, jot them off to the side, and we can discuss these next time we meet. Okay, so this is our last x-intercept example, and notice that this graph doesn't even touch the x-axis. So this is an example of no solution, or no x-intercepts, or no roots, or no zeros. It is completely above the x-axis. Now, if your graph opened downward and had no solution, it would be below that x-axis. See? So depending on which way it opens, it could be above or below. So for this one, the vertex is right here. It looks like 1, 2. The coordinates are really hard to see, but it's 1, 2. There is no x-intercept, none. the axis of symmetry, remember, goes through that vertex, and it's always x equals the x value of the vertex. So x equals 1. All right, we're moving on to the 5th page where we'll talk about the last 2 parts. All right, the last 2 parts we're going to talk about are the y-intercept and the domain and range. And you've heard of both of these as well. The y-intercept, you guys know, is where a graph crosses the y-axis. So in this case, it's where the parabola crosses the y-axis. And it's the opposite of the x-intercept. So this is where x equals 0. Now every parabola will have only one y-intercept, and you will always have just one. In the standard form, this is letter C. So in y equals ax squared plus bx plus c, the very last number, that constant, that's where your graph's going to cross the y axis. The domain and range, you guys know about these. The domain is actually pretty easy. It's always the same. It's all real numbers. You don't even have to look at the graph. You don't have to look at the equation. You're just going to always put all real numbers for domain. Now range is a little bit different. It's either going to be y is greater than or equal to a number or y is less than or equal to a number. If your graph opens up, if it's like the U shape, then it's y is greater than equal to that minimum y value. The minimum y value is going to be the y value of the vertex or of the minimum. If your graph opens downward like this, your equation will be, or inequality I guess would be a better way to say it, will be y is less than or equal to the maximum y value. So I'll show you what that means. Okay? So let's take a look at this guy. The y-intercept is where a graph crosses the y-axis. So you just look at the y-axis. This one crosses right here. Whoops. Right here. Sorry, guys. It's really hard for me to draw points on here. There we go. Do a big O point. At 0, -3. So in the standard form for this function, at the very end, it would say -3. Okay? The domain and range, for domain, all real numbers. You don't even have to think twice. Don't you just remember that? But for the range, let's look and see if it opens upward or downward. So it opens upward, which means we're going to have y is greater than or equal to that lowest y value. So if we go to the minimum, that vertex down there, it has coordinates -1, -4. This y value goes with the range, -4. So if you know the vertex, you know the axis of symmetry and the range automatically. Let's try another one. All right, so the y-intercept for this graph looks like it's up here somewhere. We can't exactly see it. So what we're just going to say is we can't tell from the graph. There is one, but we can't tell. We might also need to see, the equation of the function to get some more information. So we'll just say can't tell from graph, but it's up there. For the domain, all real numbers. And since this graph also opens upward, it's going to be y is greater than or equal to that lowest y value. That means all the other y values are greater than or equal to that lowest point. That lowest point is this minimum, which has coordinates 3, 0. So that lowest y value is 0. All other y values are greater than or equal to it. Let's try one more. All right, the y-intercept here is right there. It's very hard to see, but that's coordinates, that's coordinates 0, 5. For the domain, all real numbers. And this one also opens upward. So it's going to be, for the range, y is greater than or equal to that lowest y value, the y value of the minimum. Remember, if it opens downward, it's going to be y is less than or equal to that highest y value. So since this minimum is 1, 2, I think it is. It's really hard to see. It's this, for the range, it's y is greater than or equal to 2. Okay, so now we're going to put it all together. So we're going to put it all together. We've got the equation and the graph, and we're going to try to find all of these parts that we just talked about. So remember, for vertex, vertex is either the very top of your graph if it opens downward, or the very bottom of your graph if it opens upward. In our case, since ours opens downward, it's that top guy, which has coordinates 1, 4. 1, 4. Remember also that vertex is h, k. And since the equation that's given to us is in vertex form, this is your h and this is your k. 1, 4. It's right there. We'll practice that later. Axis of symmetry. Axis of symmetry goes through that vertex. Vertical line. It's always x equals that x value of the vertex. So in this case, it would be x equals 1. All right. Whenever I do the vertex, I like to also jump down to my range. My range, since my graph opens downward, it's going to be y is less than or equal to the y value of my vertex, 4. All of the y values are less than or equal to that top y value of 4. All right, let's go back to the x-intercepts. That's where your graph crosses the x-axis. This one crosses twice. The one on the left is -3, 0. The one on the right is +5, 0, it looks like. So -3, 0 and 5, 0. And these x-intercepts, remember, they're also known as zeros, solutions, and roots. These are real important. These will be really important when we start to do word problems with these. The y-intercept, that's where your graph crosses the y-axis. So that's right over here, and it's, right around here, and it's very hard to tell. It's some number between 3 and 4. We can just kind of guess in this case. So we could say maybe 0, about 3 point something. I'm just going to put a question mark. 0, 3 point something. Cannot do my 3's. All right. And then last is domain. You don't even need to think twice about domain. It's always all real numbers. All right, so this is kind of like our intro to quadratics. You see all the parts. There's basically 6 parts. Domain and range usually go together, so it's kind of like 5 parts. So on the very last part of your notes, in your own words, you're going to write your own definition of each of these parts and try to make some connections between the parts. This is really going to help as we go into some more of this. All right, I am going to be looking for this summary part that you're adding to your notes. This is in your own words. If you don't have this, you won't get the full credit. Okay? Bring your questions to class. See ya soon.